for any of the basic functions, we start off by listing these x values. We're going to make a table of y versus x, and that's something you're familiar with. You're probably familiar with doing all your calculations with a calculator too, and you're not going to be able to do that. But the calculations that you have to do are really very easy if you understand these rules. And if you don't understand these rules, it's probably because you've overused the calculator because the curriculum allowed you to do that. Okay, well, anyhow, and it's not difficult, but you have to practice it, especially if you're not used to it. Okay, so any basic function, we start off with this table. So, now let's do a table for the basic function y equals x squared. Okay? And that's actually quite easy. You got x here, you got y here, and you write down those values, which
I just think, well, this day I did
as soon as you understand the picture of the basic values or remember what they are, and with a little practice you'll remember them quite easily. We start off with this. Now if y equals x squared, then we're going to say, okay, y equals x squared, just to remind ourselves of what we do. Okay? Now, so if x is 2, then what is x squared? Well, it's negative 2 squared. Negative 2 squared, and it means the whole quantity, negative 2 squared, is 4. Negative 1 squared is 1. Negative 1/2 squared is 1/4. That's because negative 1/2 multiplied by negative 1/2 is 1 times 1 over 2 times 2, which is 1 over 4, and hopefully you know that, but the curriculum is very deficient with fractions, so you might have trouble with that. And we'll address fractions with some detail next week. Okay, so anyhow, we have this. And of course, if it's two negatives, so you've got to get a positive, so I didn't write that out in detail. 0 squared is 0. 1/2 squared is 1/4. 1 squared is 1. 2 squared is 2. Is 4. Now we can sketch a graph of this function. Okay, we put negative 2 on one side of the origin, 2 on the other side. Split that interval, the interval between each of these and the origin, we get negative 1 and 1. Split each of these intervals, we get 1/2, and we get negative 1/2. And this is the way I recommend you actually draw this thing. Okay, then we have to scale our y-axis. Now I can't use an interval this long to scale the y-axis because I need y to go up as high as 4. I'd have to go up, and I'd have to go through what I've written here. I didn't have to write that there. I could have allowed an equal scale, but what I want to emphasize is it doesn't matter what scale you use for y as long as it's a consistent scale. It doesn't have to be the same as the x scale. So I need to go up to 4, so I'm going to write 4 here. And then I got to subdivide that so I can see where my units are. Well, that's easy. I subdivide this interval, I get 2. Subdivide this, I get 1, and I get 3. Okay? And I'm not going to label all those numbers, but there are my units. And now I easily plot the points. Negative 2, 4. When x is negative 2, y is 4. So let's see, for x equal negative 2 occurs everywhere on this line. For every point in this line, the x-coordinate is 2. And for every point on this line, the y-coordinate is 4. And at this one unique point, x equals 2, negative 2, and y equals 4. Similarly, x equals negative 1 on a line, vertical line through the negative 1 point, and y equals 1 on a horizontal line through the y equals 1, and we have this point. similarly, we get negative 1/2, 1/4. Now, where's 1/4? Well, if this is 1, then we subdivide that, we have 1/2, and we subdivide that interval, there's 1/4. And there's the x equals 1/2, so we have a point here. And then we have the point 0, 0. And then we have the point 1/2, 1/4. We've already got the 1/4 line there. 1, 1, well, here's the y equals 1 line. And 2, 4, right there's the 4 line, there's the 2 line. You get these points. Now this should be familiar to you, you've done this. And then we can connect these points with a smooth curve, and we get this parabolic graph.